Hello Future Peace, this is Asghar. I'm a licensed professional engineer in US and Canada. I've authored several books on the topic of FE Electrical and Computer exam, as well as a PE Power exam. I run popular programs for FE Electrical and Computer exam preparation and the PE Power exam preparation. In this video, you're going to see me answering questions from my students, which I received during a live training session. I conduct live training classes for FE Electrical and Computer exam program, as well as a PE Power program. This particular question relates to instrument transformers. When you start your preparation for the PE Power exam, this is one of the very first topics that you encounter. And guess what? Within the PE Power Reference Handbook, there is no such thing as instrument transformers. It does show up in the specification as a line item for exam preparation, but the reference handbook, the latest edition that is present right now, is not including any details about instrument transformers. That does not mean that they're not going to test you on it. In fact, if you pull up the NCEES PE Power Sample Exam, you're going to see questions related to instrument transformers. And the way that I've broken up this particular concept in my program, the way I've explained it is by means of multi-part lecture series. And you'll see that in my response to the question that the student asked, I take a first principle approach in explaining this concept, which in my opinion is crucial for your success on the PE Power exam. If you're interested in learning more about my PE Power exam preparation program or the FE Electrical and Computer exam preparation program, please visit my website www.studyforfe.com. Before we dive into the content, I would really appreciate if you could like this video and subscribe to the channel to stay in tune for additional content on FE Electrical and PE Power exam preparation. Okay, so the first question that I received regarding instrument transformers, and this is not in any particular order. I've just organized them based on the topics. So the student asked, I'm watching instrument transformer videos. Based on my learning in your videos, I learned instrument transformers do the protection and metering. Are instrument transformers providing control beside metering and protection? So kind of open-ended question, very general question, right? And I do encourage students to ask these type of questions and research and think about them and, try and make sense out of them. So my general response was that, yes, instrument transformers are the eyes and the ears and relays are the brain. The combination of instrument transformer, which is basically seeking these inputs. So that's basically like your eyes are visualizing, are basically getting the visual input, right? Your ears are basically hearing, right? And then your brain is processing, making sense of everything. You guys know that the way that actually we see is inverted. Eye is a lens, and then basically it's inverted back in our brain, right? So the brain makes sense of everything. And the idea is that instrument transformers are getting the input at different nodes, different locations within the power systems network, measuring the current, frequency, voltage, any other parameter that you want, right? And then the relays are basically making sense of all of that. So although this seems like a very fundamental basic question, right? When it comes to the PE Power exam, we need to make sure, as I'm saying, we need to understand the basics, okay? And ask yourself very fundamental questions. And you're going to see some of these type of questions repeatedly throughout this session where students have asked these questions, okay? Even if you're an experienced professional, and the person who asked me this question has tons of experience under his belt, okay? So make sure that you create your understanding from ground up, not under any assumptions, but with thorough understanding, and relate the theoretical principles to real life settings. Any questions, guys? Any comments? Any thoughts? Is it just one instrument transformer per phase all the time? Yeah, for a 3-phase setting, we use one instrument transformer per phase. And the configuration of the instrument transformer, as you advance in the course, you're going to see that when we deal with the protection and control, especially differential protection for 3-phase transformers, it becomes very tricky. But let's keep things simple for the moment, okay? All right, the next question I have over here is, hi Wasim, in this question attached, and this is a question from the mini exam, why didn't we use 20 times 5? So 20 times 5, guys, what is this 20 times 5? 20 times 5, what is 20 and what is 5 here? Okay, so it's more generally, it's called the 20x rule, correct? The 20x rule. And where's the 5 coming from? What is the 5 here? The 5 is the secondary amps, correct? So 20 times 5, right? Now this 20x rule, those of you who have gone through the on-demand content and in the live training recording as well, when I went through that, I told you guys that we need to be a little bit careful with using the 20x rule blindly. because in reality, this 20x rule really applies, and I'm just talking in general terms right now. It really applies to scenarios where the CT has the rated burden connected, correct? And what happens at the 20x rule? So the idea is that if we have 20 times the secondary amps flowing on the CT, let me just quickly sketch it, right? So if this is whatever 5 amp CT, right? I don't care about what is on the primary, but the secondary is 5 amps. So the 20x rule, if you just blindly apply it, what it tells you is that if 100 amps are flowing on the secondary of the CT, right, then what happens? You're going to maintain the ratio error less than 10%. In other words, that basically means that the CT will not get saturated. But there's a catch over here, guys. What is the catch? The catch is that this 20x rule, the underpinning of the 20x rule is that the load that is connected, or the burden, in more specifically, technically speaking, more accurate term is burden, which includes the resistance of the wire, the CT's own impedance on the reflected on secondary, plus the relay or whatever device is connected. So if that total burden is equal to the CT's rated burden. Now let's assume that this CT is a 0.9 ohm CT or 0.1 ohm CT, right? So as long as we do not exceed, right, that burden rating, then we can have 20 times current flowing on the CT secondary, and it will still be able to maintain this 10% ratio error. Is that clear? Now, what will happen if the burden, let's say, is 0.1 rated CT, right? The B0.1 CT, and I end up connecting B0.2, 0.2 ohms on the secondary. Do you think I'll still be able to pump 100 amps through the secondary of the CT and maintain the 10% ratio error? If the actual load that is connected on the CT exceeds its burden rating, I cannot. Okay. And in contrast, if this is 0.1 rated, and if I connect 0.05, so half the allowed or half the maximum, then what will happen? Can I pump more than 100 amps in order to maintain 10%? Yes. Okay. So this 20x rule, and this is what I'm saying, whenever we are dealing with rules of thumbs, we got to be really careful, right? In practice, when you're actually working in the field, in the industry, and also during the exam. So we explored this particular concept in a lot of depth in the on-demand course, as well as I commented in the live training. So the answer to this student's question directly was that this 20x is in the context of 10% ratio error. Now, when we go through this question, this is from the mini exam. The burden designation is 0.9. Okay, and it is connected to a measuring instrument. I'm being a little bit vague over here. This measuring instrument can be anything, right? And that device, so the device that is connected over here, right, that is 12.5 VA. Okay, so determine the maximum wiring burden. So the equation is for burden is CT's own resistance, correct? The wire resistance, which is unknown, and the device impedance, which is given to us, but in VA, okay? And what is our assumption over here? Our assumption is that since the CT resistance is not given, so we can assume it to be 0. I commented on that. Although in this case, maybe I should update the question and make it even more clearer. So the question mark is over here. So this 12.5 VA is equal to I square R. I know is equal to 5. So 5 squared, so 25, right? So I'm able to convert the 12.5 VA into ohms over here, right? And I know that I cannot exceed the 0.9. Where is the 0.9 coming from? The 0.9 is my CT's burden rating, right? So I rearrange the equation, and that tells me that the wire resistance should not be greater than 0.4 ohms. It's a simple, straightforward question, but I included it because I feel that there are some underlying concepts that we can brush up on. Okay. If the CT has multi-ratio, is that why you want the largest ratio of the multi-ratio to not saturate? Yes. Yeah. So the multi-ratio or the multi-tap CTs, remember, we have a few practice problems in the homework assignment. I don't remember which practice problem it was, but I gave you I think a 1200 to 5 amp CT. Does it ring a bell, guys? And then I asked you to calculate the maximum saturation voltage. And then I asked you that, okay, if I was to operate the CT at a tap of, I don't know, 1000 to 5, what will be the maximum allowed saturation? 1000 to 5. Okay, good. Yeah. So that basically answers that question. Yeah, if you operate a given CT at different taps, then the maximum voltage that is allowed on the secondary, and maximum voltage is a function of the current that is pumping through the secondary of the CT, that will scale accordingly. Clear? Okay. Another comment I want to make, I did mention this initially, is that CT burden, excitation, accuracy, errors, rating, construction, safety, and so on are not mentioned in the NCEES Power Reference Handbook. In fact, the entire topic related to instrument transformers is missing, right? And in some ways, these concepts are actually going to make even more impact when we get to protection and control, because we're going to be deploying the CTs for our relays. So why is it that we are going through these concepts in depth? Because, as I pointed out upfront, when it comes to the P-Power exam, guys, you have to be prepared to tackle things that are not explicitly listed in the reference handbook or the specification. And if you don't want to take my word for it, check out the sample exam. Okay. They cast a broad, net when it comes to testing your knowledge. And not only that, they're going to ask you questions in ways that even if you know that topic at a mediocre level and are not able to understand, the nuance with regards to the terminology, with regards to the theoretical concept, following that question in the right direction is going to be problematic. And it is one of the biggest challenges on the P-Power exam. Okay. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and P-Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.